Good morning. So today's lesson is on fundamental forces in nature. You have come across various types of forces around you. For example, you told me yesterday about the forces like frictional force between objects, electrostatic force of attraction, then you have elastic forces, and also the force that holds the atmosphere bound to Earth, the force that holds us to Earth, and also the force between Earth and other planets, Earth and Sun. That is the gravitational force. So you have come across a lot of forces in physics in your study from maybe from grade 5 to grade 12. You have come across a lot of forces, and also in your practical life you are seeing lot of forces. Now all these forces can be unified or classified into just four fundamental forces. Whatever kind of force that come across you will be one of these four kinds of forces. So what are fundamental forces? Those forces which are fundamental, which means they do not originate from other forces, but all other forces can be expressed in terms of them, are called fundamental forces. In grade 11, you must have learned about fundamental quantities. Do you remember what are the fundamental quantities? What are the fundamental quantities or basic quantities? And
Mass.
mass, yes, you are right. Mass, length, time. Then you also learn few more like temperature, etc. So these mass, length and time are three quantities which are fundamental, which means many other quantities can be expressed in terms of that. For example, speed can be expressed as length by time, right? Force can be expressed as mass into acceleration, which is mass into length by time square. So these are the fundamental quantities in terms of which all other physical quantities can be expressed. In the same way, all the forces in the universe can be expressed in terms of just four fundamental forces. So let us see what are these four fundamental forces. The four fundamental forces are gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. You must have already having some idea about these three. Can you tell me what is gravitational force? What is gravitational force?
The attraction between any two bodies of the universe.
The force of attraction between any two bodies having mass is called gravitational. Can you give me some examples for gravitational force?
Like the sun and the Jupiter.
Sun and Jupiter. Yeah, why you forgot Earth? So
Because
all
that's
planets.
gravity, right?
Yeah, it's great. It's large because they are massive. That is massive. So all the sun and all planets. Also, we are experiencing gravitational force because of the attraction towards Earth. And also,
Teacher,
yes.
like we learned that any two bodies, if any one of the bodies is Earth, then it should be considered as gravity.
Yeah, gravity. Gravity is also a kind of gravitational force. It's due to the mass, an attractive force due to the mass, right? It depends upon the mass of the object and the distance between them. So the law that obeys is called gravitational force. So it's all kind of gravitational force. Now, what is electromagnetic force or electrostatic force? You have learned like the force between charges. And later we learned that magnetism is also interrelated with electricity. So they are inseparable now, electricity and magnetism. So that kind of forces are called electromagnetic force. That is a force between two charged particles. Now, what is strong nuclear force? It's the force that binds the nucleus together. It's called strong nuclear force. And weak nuclear force is a kind of force which comes into play only in certain nuclear phenomena. So we will see in detail today each of these kinds of forces, and then we will compare between these fundamental forces. So let us see each of these kinds of forces. So first of all, let us see what is meant by gravitational force. And when we see it as a fundamental force, what are its peculiarities? So what is a gravitational force? You all know that the force of attraction between any two objects of the universe due to mass is called gravitation. So mass, due to mass, it is very important. Now, what causes weight of a body? What causes weight of a body?
Gravitational constant.
Yeah, it is due to the gravitational constant, or it is due to the gravitation. So when the body will have more weight, when it is on the surface of earth or when it is on the surface of moon?
Earth,
Earth. Why?
because G is greater in Earth.
Yeah, on earth, G, or the gravitational constant, is greater because earth is more massive than moon. Now, if you take the same body to Jupiter, the body will experience more weight or less weight?
More.
More, because Jupiter is more massive than Earth, right? So it all depends upon the mass of the body. So weight of a body is typically due to gravitational force. And have you ever heard of gravitational repulsive force? No, gravitation is always attractive in nature, and it is the weakest fundamental force. For example, if you take a hydrogen atom, it contains electron and proton. You know, both electron and proton have mass, and even though they are very light, their masses are very small compared to planets, stars, etc. Still, they have mass. But the gravitational force between electrons and protons are 3.6 into 10 raised to minus 47 Newton. While the electrostatic attractive force, you know, electrons and protons have opposite charge. So they attract, and that kind of force is called electrostatic force. So that between them is 8.2 into 10 raised to minus 8 Newton. See the difference?
Teacher,
Yes. Yes. Tell me. So when you take the particles, if they are very,
Teacher,
yes, yes,
can you
teacher,
what?
repeat that? Can you repeat that neutron
teacher,
part
can you
again?
listen me?
Like I'm telling that in the case of a hydrogen atom,
Hello.
we have
Yes, teacher.
electrons and
The mass of Mars is greater than Earth, right?
what?
The
Mass
mass
of,
of Earth, Mars is greater than Earth, right?
for what? Jupiter? You are talking about Jupiter? So I was telling that in hydrogen atoms, see the protons and electrons, even though they have less mass, there is a gravitational force between them, and it is very less compared to that of the electrostatic force between them. See, this is 10 raised to minus 47, and this is 10 raised to minus 8. So, see, around 10 raised to 36 times more than the gravitational force. So the electrostatic force is much more than the gravitational force. We told that gravitational force is between any two objects, right? But it will be appreciable only if the masses are large. When the masses are very small, The electrostatic force will be more dominant compared to the gravitational force. And it is universal. Gravitational force is universal, means it acts between all the objects in the universe. It has no peculiarity like it will act between charged particles, nothing like that. It will act between all the particles. And gravity governs the motion of satellites around planets, planets around sun, and also the solar system in the galaxy. So all these uh, macroscopic things are the big part of the large scale mass of the universe is governed by gravitational force. So even if it is the weakest force out of the four fundamental forces, it plays a key role in large scale phenomena of the universe, such as the formation and evolution of stars, and the formation of the universe, formation of the galaxies. So these all are related to very massive objects. So, and the gravitational force has infinite range. The range is very large. So we know that all these objects are spaced at large distances in the universe. So the gravitational force have infinite uh, range. So it can play an important role in the force between all these massive bodies in the universe. Now, we think that the scientists think that it is due to the mutual exchange of a type of particle called graviton that the gravitational force acts between particles. You also call the gravitational force a force at a distance, because even if the objects are not touching each other, even if they are not in contact, the gravitational force will act between them. And it is due to the mutual exchange of a basic particle called graviton. And this is just an assumption. We have never identified the particle graviton yet. You are looking forward to it. Theoretically, it is predicted that it may be due to the exchange of a type of particle. In fact, all these fundamental forces are due to the exchange of a fundamental kind of particle. For the case of gravitational force, even if experimentally we have not proved that, theoretically, due to symmetry, we expect that it should be due to a particle. And we have already named the particle as graviton, though it is not experimentally confirmed. Is that clear to you? The gravitational force and its peculiarities?
Yes, teacher.
Okay. So let us see the next kind of fundamental force, that is the electromagnetic force. Now, what is electromagnetic force? The force of attraction or repulsion applied by two charged particles due to their charges is called electromagnetic force. So from this definition itself, you can find two differences between electromagnetic and gravitational force. What are they?
That electromagnetic both have attraction and repulsion.
Yeah, it can be either attraction or repulsion. What else?
It's because of the charge, and that one is mass.
Yeah, gravitational force is basically due to the mass of the particles, while electromagnetic force is due to the charge of the particle. And this is a similarity. The range of electromagnetic force is extended to infinity and does not require any intervening medium. So it's similar to that of gravitational force, like its range is also extended to infinity, though as the particle go far apart, the strength of the force decreases, but it goes to infinity and it does not require any intervening medium. Even if it is vacuum between the two objects, it can act. And it dominates all the phenomenon in atomic and molecular scale. Can you guess why it dominates all the phenomenon in atomic and molecular scale? Why? What are atoms made of?
Proton and electron.
Electrons and protons, both are charged particles, and these molecules are made of more
Charged particles.
atoms. So fundamentally, all particles are made of these charged particles, electrons and protons. So all the phenomena which we can observe are due to the electromagnetic force between them. So it
Teacher,
governs the structure. Yes.
so what is intermolecular force then? One type of electromagnetic
Intermolecular means the forces between molecules.
molecules. Then we can't consider it's also a electromagnetic force.
That is also electromagnetic in nature because they are basically because one molecule is formed by the combination of atoms. How the atoms combine due to sharing of electrons or due to exchange of electrons, right? So the charges are involved. And also due to unequal sharing of electrons, there will be intermolecular forces. So all these are due to basically the charge of electrons and protons. So the force that exists in all that domain is fundamentally electromagnetic in nature. So it governs the structure of atoms, molecules, and also chemical reactions. What is involved in chemical reactions?
Charge also, right?
Molecules, electrons, basically. It's the exchange or the change of electrons. So all chemical reactions are governed by electromagnetic force, and also the thermal and other properties of materials. Why a property gets heated up? Due to the vibration of atoms and the atomic subatomic particles. So all these areas, whatever force you learn in these regions, are all fundamentally electromagnetic in nature. So another kind of force, frictional force. When will friction occur?
When two of particles collide each other
Collide each other or try to move. One
on each
object try
other.
to move on the surface of other. So it's due to the irregularities on the surface at the atomic scale, at the molecular scale. So it's also a kind of electromagnetic force. Contact force also occurs when two bodies are in contact. So it's all atomic and nuclear level. When we think of them, they are all basically electromagnetic. Spring force and also other, can you tell other forces which will come in this category? A force that lead to the deformation of object.
Elasticity.
Yeah, elastic forces, they are all electromagnetic in nature. And it is due to the exchange of massless and chargeless particles called photons. So I told that all these fundamental particles, the scientists think they are due to some particles, right? So there is a basic reason for the existence of each of these fundamental particles. For gravitation, we believe it is due to gravitons, and for electromagnetic force, the fundamental particle responsible for that is called photons. What are photons?
Particle of light.
Yeah, particle light or quantum of light, we tell. It's a quantum or photon. So it's the reason that is what we are thinking now. And you know that photons are already experimentally identified. Now, I have a question. We told that there is gravitational force acting between any objects in the universe. For example, I am holding my phones. See, you can see here, I'm holding my phone here. You can't see me, right? Okay, I'm holding my phone here in my hand. Why don't the phone pierce through my hand and go to ground? A book kept on a table. Why don't that book pierce the table and go down?
It has a barrier, right?
Yeah, why there is a barrier? Like the book, even suppose a table weighs 2 kilograms, suppose. Even if you keep a 5 kilogram mass on that table, it won't pierce the table and go down to earth, because the earth is attracting that object with more force than the table. Still it is not going. Why?
If we keep more than 5 kilo, maybe it can break, teacher.
It may break, but mostly, even if the gravitational force on the 5 kilogram mass is more than the 1 kilogram, still it is not piercing the uh, table and going down. Why? Because the atoms and molecules of the table are held together by electromagnetic force, which is much more, around 10 raised to 36 times that of the gravitational force that attract the object towards earth. So it is not piercing through the object. If it has to pierce through the object, it have to overcome the electromagnetic force that is attracting the molecules within that within the table together, right? So it's because the magnetic force is much more than the gravitational force. We are not observing or realizing the gravitational force between objects. See, we told that there is gravitation between a table and a chair, but are they moving towards each other?
No.
Can you see it automatically moving towards each other? No. Why? There is a frictional force between the ground and this table and chair, which is much higher than the gravitational force of attraction between them. So it's because the electromagnetic force is much more dominant or much more stronger than the gravitational force. You can't see the objects directly coming together due to the gravitational force of attraction. See, a court and a table, there is gravitational force. They are not moving towards each other because of the frictional force, which is electromagnetic and many times stronger than the gravitational force. Is
Teacher,
that concept clear? Yes.
electromagnetic force is constant.
No, it depends upon the objects, the
Charge.
distance between them. You have learned F is equal to
Like,
Q1, Q2 by
yeah,
our
yeah, yeah.
scheme. Okay. So it depends upon the objects, their charges, and also the distance between them.
What if we keep in a planet, having more than gravitation constant than Earth? Like, in that planet, the gravitation constant may be greater than that.
Yeah, then the electromagnetic force between the objects will, that
Would be
hold
more
the
great.
object together also will be greater, right? Anyway, it's
How?
10 raised to,
Because we are not changing the particles, right? Like, if we keep a
yeah, yeah.
same the table,
Uh,
that table in that
yeah,
planet, then
the nature of the particle is not changing.
yeah.
And there are some times, like for example, in a black hole and all, it is formed by the contraction of the object due to its mass. Stars, how do a star die? It's because when it becomes, as you told, if it becomes very, very massive, like around 10 raised to 30 times and all, than the mass of Earth and all. So the gravitational force dominates there, as you said. So it contracts within itself. So if the mass is too high, then of course the gravitational force dominates. And so let us see the next kind of force called the strong nuclear force. See, strong nuclear force. Now, strong nuclear force exists only between two kinds of particles. What are they? Protons and neutrons. It doesn't affect the electron at all. Now, you know that inside a nucleus, you have protons staying together, right? You know that two protons are positively charged. They should repel each other. Why they are not repelling? Because inside a nucleus, there is a force which is stronger than the electrostatic repulsion between them, which is called the strong nuclear force. The force that keeps the nucleus together is called the strong nuclear force. And just like gravitational force, it is always attractive. Strong nuclear force is never repulsive. It's always attractive like gravitational force. And it is the force that binds the protons and neutrons in a nucleus. And it is responsible for the stability of the nucleus. If there were no strong nuclear force, what happens? The electrostatic repulsive force between protons and proton will come to act, and the nucleus can never attain stability. It will not be stable. So it is the strongest of all fundamental forces and about 100 times the electromagnetic force in strength. That is why nucleus is so stable. It is 100 times stronger than the electromagnetic force. So even if there is repulsive force between two protons, when it comes to the strong nuclear force, which is 100 times stronger, they will stay together. And it is charge independent and acts equally between proton and proton, neutron and neutron, and proton on neutron. It doesn't affect the electron. It affects only the protons and neutrons. Now, we told that gravitation is between particles having mass. Electrostatic force are between particles having charge. So like that, how can we tell the strong nuclear force is particles made of quarks? Because both protons and neutrons are made of more fundamental particle called quarks. Electrons are not made of quarks. Electrons are themselves fundamental in nature. They are not made of any other particles. But protons and neutrons are not fundamental in nature. They are made of quarks, which are kept together by the exchange of adhesive particles called gluons. So, what is the particle which is responsible for strong nuclear force? It is called gluon. Gluon is the basic particle. Okay. So for gravitation, it is graviton. For electromagnetic, it is photons. And for strong nuclear force, it is gluons. And its range is very small, around 10 raised to minus 15 meters. That is almost the size of a nucleus. So if two protons move further apart, strong nuclear force will not come into play. If they are further than around 10 raised to minus 14 meters, nuclear force is not there to play. So there will be electrostatic repulsive force and they will go apart. Is that clear to you what is strong nuclear force? Is that clear?
Yes, teacher.
Okay, so let us see the last fundamental force, which is weak nuclear force. So what is weak nuclear force? It is the short-ranged and short-valued force which acts within the fundamental particles of nucleus.
Teacher, can you repeat the last line?
Like
I
what
got
is
the
weak nuclear force?
range.
Yeah, the range is very small for a strong nuclear force. It is around 10 raised to minus 15 meters, which is the size of a nucleus. Okay, so if the protons are staying inside the nucleus, they are very close together. So their distance between them is around 10 raised to minus 15 or 10 raised to minus 16 meters. So it doesn't matter. Even if there is a electrostatic repulsion, there is 100 times stronger nuclear force that attract them. So they will stay together. But if they go further away, if they move out of the nucleus, the distance between two protons will be more than 10 raised to minus 15 meters. In that case, what will happen? The strong nuclear force have no role now. The strong electromagnetic force will repel them. So the protons will no longer stay attracted. So they will stay attracted only when they are within the small range, that is 10 raised to minus 15 meter. Is that clear, Zaman?
Yes, teacher.
Okay, so let us see about weak nuclear force. I think the time is going to end, and I will discuss weak nuclear force and also the comparison of all four forces and the attempts made by different scientists to unify them in the next class. Just let us have a short idea what is weak nuclear force. See, the weak nuclear force comes into play in certain kind of radioactive decay. Have you learned about radioactive decay?
Half-life, that
Radioactivity.
one.
Yeah, tell me, what is radioactivity?
Like which the particles which can emit radioactive
Yeah,
rays.
radiations. Nucleus emit radiations. What are the radiations emitted?
Alpha ray, gamma ray, that one.
Yeah, alpha, beta, and
Beta,
gamma.
gamma.